So, we've recently covered equivalent fractions and some of their uses in finding which is the larger fraction, comparing the size, and then to find things like fractions that are halfway between. So, let's look at another place that equivalent fractions can help us. So, if I've got 3 £20 notes and 1 £10 note, you can describe that as £70. If you've got 3 5-kilogram bags of something and you've got 2 10-kilogram bags of something, you can describe that as 35 kilograms. These are combinable. What do we do in a situation where we have 3 meters and 20 centimeters to add together? Well, the difficult part is they're in different units. So we could say we have 3 meters 20 centimeters. We could say we have 320 centimeters, converting our 3 meters, or we could say 3.2 meters, converting our 20 centimeters. Of these options, the first one is not ideal and the other two are good, where you use the same units. Now, I'm not talking about fractions yet, so you might be wondering, where is he going with this? Well, let's now look at some fractions. And let's start with a fairly common one that most people can work out even if they haven't understood a lot of fractions so far. A half and a quarter. Now, most of my diagrams so far have been using lines to describe whole ones, and I'll do that here, but I'll also draw a pizza shape because I think that this will help a lot of people. A half, there it is. If I was to add a quarter to that, there is a quarter. How much have I got? Some of you will instinctively think, well, actually, a half there and there is 2 quarters. So the answer is 3 quarters. Now what you did in that question is exactly the same as the person who gave 320 centimetres or 3.2 metres. You took a situation where you had differing units or differing denominators and you made them equivalent. And you did that in a really simple way in your head. Now, let's try that again with slightly less obvious numbers and see if we can do it. Okay, slightly trickier situation here. Reminder that the denominator is the size of the piece. It tells you how many pieces of that size make one whole one. So 5 of these pieces makes a whole one, and we have 2. And 3 of these pieces makes a whole one. Sorry, 10 of these pieces makes a whole one, and we have 3. They are different sizes. So how are we going to combine these? We'll start with a diagram. So we start with 2/5. There they are. I want to add 3/10 to this. Well, in order to add tenths to this, I would need a whole one that's chopped into 10 pieces. Let's draw that underneath. To make this easier to see, I'm going to draw my 3 pieces over here. You can see the pieces are not the same size. So in describing my answer, I'm going to have difficulty. If I take these 3/10 and I draw them up here, they come to there. So the question is, what fraction have I just drawn? Can I describe it in fifths? Well, I can, but actually it's quite tricky. That would be 3.5 fifths. And in a fraction, I am not allowed to use a non-integer in the numerator. So that's a problem. Is there another way of describing it? So these fifths are too big. What if I brought these two down here instead? There's 1/5 and there's 1/5. So you could describe it as 7/10. Well, that seems to make more sense. And that is correct answer. How shall I write this out to describe what I've just drawn? Because whilst with this example, it's easy to draw a diagram, if the numbers became really tricky, like for example, 27 over 52 plus 73 over 97, I don't want to draw this out. So, let's set this out. I started with 2/5 add 3/10. Now in maths we work down the page, so my instinct is to put an equal sign here to carry on the sum. Now what I actually did here in the diagram to make counting these up possible was I took these 2/5 and I redrew them here. What did I redraw them as? I redrew them as 4/10. Now, remember what we talked about with equivalent fractions. We can multiply both parts of a fraction by the same number to change it. It still has the same value, but we can use this new fraction to work other things out. We can also simplify fractions where we need to. We kept our 3/10 the same, and then we were confident enough to say, well, that's 7/10. So we used equivalent fractions to create the same denominator. In this case, we changed one fraction by multiplying both parts by 2. Then when we had the same denominator, which means the pieces are all the same size, we counted up how many pieces we had. We'll do some more examples in the next video.